We will start, sir.
We will start.
Zoom we are in, YouTube also we are now. We'll wait for question.
Yeah, we will wait for 3:50. No one comes up to that.
No, actually, Harsha should have worked it. Yeah, for student.
They tried it from. I was not here, so I didn't have the book to know even what's the question.
That's fine, but he's
But I got that. This is that minus Laplacian something. What is the question?
Laplacian u minus u is bigger than or equal to 0
Okay.
in Rn, and u is C2 and bounded up.
Okay.
Then it has to be less than or equal to 0. Fine. Sometimes you get.
No, that's good. Our books are many places. Somewhere in Japan, I met two people from many people Northeast. And later I'm following the book. And our book once it establishes and people studying will start using it. Next generation.
Next gen, yeah.
More that's at least even now it's very
next month, right? Next month will be getting it, or by end of this month.
Nice. Good is in the NBA to send it to the university. Okay. Yeah, probably teaching this course may be easier than the other. It was more painful.
Yeah, painful in the sense it's all preliminary, not preliminary, but some
basics.
pre-revision and what to do, what not to do, and so technical, right?
It's so technical.
That the extension theorems and
so technical.
My God. And even distributions, you did it in so much detail, finite order, compact support, this, that, so much, right? My God, if you see the material and you really work it out, see, you realize only when you come out and see. Right?
Yeah.
So much material. So much material.
Yeah, now they cannot say that they don't have lectures. They have something book is there. Recorded lectures, the public can everything is available. Of course, it's recorded. Yeah, it was tough to teach these topics. Anyone join anywhere, YouTube or anything? Anyone through YouTube? Usually it comes there. Yeah, some questions.
Question or somebody joined.
Yes, somebody joined. This hours is not. Any questions from anybody?
Has someone joined?
I don't know. YouTube watching, I don't know. They can join.
Oh, okay.
Who they ask questions. Or maybe, can anyone tell me? How the YouTube, if they have questions,
Yes,
they can
one
ask.
question.
How do you check the questions?
Yes.
What is it?
Good afternoon, sir. The lectures are good, but in preliminaries, more explanation needed, sir.
Okay. Yeah, that is true because this is an advanced course. Not come. Yeah, this is a very advanced course. We expect students to learn preliminaries by themselves. Idea of giving few lectures on preliminaries so that you get an idea what to look for and what to look for. So if you try to spend time on preliminary, we will not be able to cover. But having said that, any of you have any questions regarding preliminaries, they can write to us. That's no problem. Either we can talk to TAs through the sessions. You can raise your questions there. You can also write to us. That's fine. Yeah. But we cannot spend more time. I understand your question is valid. But unfortunately, this is a slightly higher level course. Not higher level, it's a first course on PDE. But the motive is to study PDE through analysis. As we keep on telling that in most of the universities, PDEs or differential equations are taught like a problem solving sessions. And the whole purpose is to make a change in that aspect. Yeah, so is that okay? How did they get the questions? More questions. Or if you have anything specific, you can explain. You can click on this thing. Then any questions coming? Please. Yeah, one more comment is that, but some of the preliminaries, like test function spaces, etc., you can study still distribution theory without getting into too much details. But it's important to have a good course on functional analysis. Without a good course on functional analysis, you cannot study PDE in general. But you don't have to understand all the locally convex topology, etc. You can somewhat bypass to study the course and the next course. That's for the next course. This is the first course on PDE. So we will be offering the second course, advanced PDE course, in the another 2 courses. Yeah, but functional analysis is a must. Yeah, so get strong in your real analysis and functional analysis. These 2 courses, you should have a thorough idea, like of LP spaces. And some sort of an integration. and also a bit of multivariable calculus. Any further questions from the same person? Or which part of basics you find it difficult?
Not explained.
Not
Not
explained.
explained much.
Yeah.
Much.
You feel that a particular part is preliminaries has not explained. You can tell us probably we can provide some supplementary material at some point in time. We can even add a video course on preliminaries as a supplementary part. That will when you reach to-
You can just log in on NPTEL site itself, right? Which one? Here.
I think they would have given a link also.
Yeah.
They can.
Like June link they have sent us.
They can. They can. And there is a YouTube also. So that can-
No, YouTube we will not be able to see their face.
Mm.
If they come in June,
Yeah, we can.
then
see
we'll
it.
know who is the
Yeah, that's true.
at least some familiarity.
Yes. True.
Yeah, instead of sitting here, our offices would have been better. Whenever there is a question, so 3 to 4, we put, put it on, and whenever there is a question, you just check it. Otherwise, you will be doing your usual.
Yeah, we could have done.
So here you should just that also is recording. Zoom meeting also recording.
Then we'll stop.
Sir.
No more questions. Okay.
I'm also checking there from the after this.
Yeah.
No questions, maybe once.
Okay, if
Oh,
there
one more question.
Yeah.
okay.
Can we? So,
Okay. Can we use Oberth spaces to develop fractional derivatives in various why-year differential equation need to have a unique solution? Okay, sir. Thank you. Can we use Oberth spaces to develop fractional derivatives?
I think they do it in a different way altogether. The doubles integral.
We do not know the exact way of answering, but then there are fractional order Oberth spaces.
Certainly, you can define those
Yeah.
fractional order derivatives, but as such, developing the calculus may be a different procedure. At least,
Yeah, we do not know that, right?
yeah, that they usually use Abel type integrals and that kind of thing. But of course, we can define fractional order weak derivatives through Sobolev spaces, but that also in only in the whole space. Of course, we can also localize it. But as such, developing the calculus, I think that's a different procedure.
Yeah, that is not, I don't
Not
familiar to
not
us.
yeah, not through this Sobolev spaces.
Why do you check it? Why-year differential equation need to have
unique question.
No need to.
yeah.
Only life would be better if it has unique solution.
Yeah, that you are perfectly right. A
Uh,
differential equation, even with conditions, need not have a unique solution. But then
in application,
in applications, if the applications gives a unique solution, you expect for an application a unique solution. And if your PDE or differential equation formed by applications, then we expect to have a unique solution. But immediately with the initial conditions, it may not give you a unique solution. That's why the Hadamard used this well-postness concept. If you have a unique and solution which are regular, then you call it well-post. It doesn't mean that it doesn't need to have that one. It can have even the ODE, PDE, first order ODE, if you have a nonlinear first order ODE, you can have two solutions. On the other hand, if it's a quasi-linear equation, unique solution. But there are systems like conservation laws. Initially, you apply weak formulation, you get multiple solutions actually. But then if the physics, if the modeling is correct, and your physical problem has only one solution, then among the many solutions, how do you pick up that solution? You need to have additional conditions, like, for example, conservation laws. You need to have entropy type condition. Perfectly right. No need to have a unique solution. The uniqueness you expect only if your physics demands it.
Closer to reality.
Yeah, if your modeling is closer to reality and your real problem has a unique solution, yes, you can have unique solution. Yeah, that's perfectly good question, and no need.
No.
Where did you get this? How did you type it there? How did you come to this thing there?
This is a chat box. YouTube.
YouTube.
Oh,
How did you go back?
this is from
And then where did you click? Where did you get that window?
same. The
Here, okay, okay.
Ah.
Yeah, 5 minutes instead.
But they should also respond, right?
Yeah,
To
no,
answer or whatever.
no, he said okay, sir.
No,
Okay.
that's what. If they are okay with the answer, they will say, yeah, okay, sir.
Ah,
Chunky there, are you convinced with our answer or do you have more questions? Chunky there. You can write your comments.
so concurrent is 4. So we 2 and just what is the exam?
What is this graph? This graph.
And then people will come and
Okay, people are coming. in.
concurrently.
Okay. Somebody asked me. There are 6 people at some point.
Well, let them post. Even today or even in future. They
Yeah,
can
that we already
they
play.
can-
Anyone has solutions, you can write to us through mail or something.
they can always post it. Right?
Yes, they can always post on Google Forms.
Yeah,
Ah,
they can.
Anytime they can.
They can even write to us.
Yeah, they can.
Email also.
Ah,
We have shared your emails to them.
so somehow in fact, if students are serious, those 8 weeks should keep us very busy. Right? There will be so many questions and
Is it possible to convert the nth some questions?
oh, suddenly
So
came up.
Simply the maximum minimum principle for PDE. Yes, there are maximum minimum principle for PDE, and in fact, we have covered that maximum principles. There are maximum minimum, but I don't see the question. So, Sarmishta, there are, yeah,
Especially for elliptic and parabolic type.
yeah, there are maximum minimum. In fact, we have discussed it. Is it possible to convert an nth order initial value problem to a boundary value problem? In general, it's not a
No, when you say initial problem, so
initial value problem.
so where are the boundary means at least you should have 2 points.
Yeah, so when you say that nth order problem, what do you mean by an initial value problem? Both the concepts are different. It's
So
not about
initial value problem, you put conditions only at one point.
at time t equal to
At time
0.
is t equal to 0.
Hmm.
But whereas boundary value problem means
Yeah,
at least 2.
at least two. So you need the boundaries. Okay. So the boundary value problem, the concept and physics is completely different. You would have seen even in the ordinary differential equations. When you have a second order, say ODE, you will have 2 initial values. So the physics is different. When you have, for example, second order ODE, when you have 2 initial conditions, you are giving the position and velocity. Okay. But the boundary value means like you are fixing something at endpoints. So you need to have the endpoint. So it's in general there's no meaning. So that basically it looks like you are trying to change the physics of the problem.
There is no connection.
No connection as such. Thank you for the session, sir. But if it is in another platform, it will be more interactive because of course, why you can come directly. You need not have to Jairam.
This
We are-
Zoom meeting.
It would have been. Are you a registered participant, Jairam?
I cannot answer.
Yeah, you can write here, Jairam.
True.
Yeah, you should be coming online. So it would have been a face-to-face interaction. I don't know, all registered participants will to the platform. So are you registered for the course? If you are registered, you would have
Then
got
we get a Zoom link.
So you would have got a Zoom link.
Yes, sir.
Yes, sir. Then you would have got a Zoom link and you would have joined. So we could have also seen you, not only here, when we visit other institute. Which institute you are from? More interactive because yeah. So I'm surprised, Jairam, how he came through YouTube only. Would have got a
Yes,
registered.
sir. We have seen all participants.
Yeah, all
who are
participants. Yeah,
registered.
all registered participants would have got a link.
The email would have the link.
Hmm.
We also got that.
Same
Oh,
same
that
email.
same thing.
Yeah. In fact, we would have been happy to see you. So, sir, I have registered Kumaraguru College of Technology from Coimbatore. Did you get a link, Jairam? For joining the Zoom meeting? This is via Zoom.
Zoom. That's what.
Jairam, did you get a link? Yeah.
Zoom meeting.
He didn't check it. I came through the remainder text message. That's okay. What is the main advantage of the initial initial value problem? Then it's not a which one is advantageous. It's not that initial value problem is better than boundary value problem or boundary value problem is better. It's about the
Physics.
it's about the physics. Okay. If the problem is an initial value problem, so the conditions are coming from physics. Okay. There is nothing like which is advantageous, which is not advantageous. But having said that, when you study ODEs, for example, generally initial value problems are slightly easier than dealing with the boundary value problem. That's a mathematical issue. So mathematically, yes, for ODE, initial value problems are in general is a little different way of handling than the boundary value problem. So there is nothing like one is advantageous and one is disadvantageous. It's all how you are solving the problem. Okay. And what kind of problems you are solving. For example, in PDE, when you solve an elliptic problem, there's no initial condition at all. There is no time because it's an equilibrium state. So you will have only boundary values. On the other hand, when you study evolution equations, heat or wave type equation, there are two phenomena happening. You have a spatial variable x, you also have a time variable. So when time t equal to 0, you will have initial values are prescribed and then boundary values are given. For example, if you want to understand the evolution of a temperature in a body, you know the temperature in the beginning at t equal to 0, and then through the boundary, you will be giving the temperature continuously. So you know the temperature on the surface, that's the boundary value, and then initial temperature you know. So the problems and the conditions are prescribed according to the physical problem. Similarly, wave equation in one dimension. You have a string and string is attached to ends. And then that end condition attached all the time. Then you have a condition all the time. But then you know the position of the string at t equal to 0. And then you are plucking your elastic thing. And then it starts vibrating. So you have it. And that's why the earlier question also, you can't convert one to another. Is that clear, Samisha? That's a nice question. Yeah, these are all maybe minor doubts. That's what is always.
Sure.
Yeah, this is the whole idea of asking such questions.
I'll copy the YouTube questions in Zoom.
You have more questions?
No, if it comes, I'll. I'll copy. We'll wait for some more time.
Yeah, since the questions okay. At least complete.
No, at least this time, the no, actually, NPTEL asked them to post queries in advance.
So
then
yeah, we can make that suggestion.
But no,
That is regularly they can ask questions. That is there in the code.
no, but even here they can, if some doubts were not clear, they can ask.
Yeah, that's a good
Posted.
idea. Posting there.
But this one shows only for
And keep on changing. Now, right now it's 4. At some point, 0 is 5.
yeah, but this number here, that is not seen.
Okay. I think this US it's used in the cases. If there are no more questions, probably we will wind up.
Yeah, that is strange. The Jairam not getting the.
No, he got it.
He got it.
He didn't check it, he said.
Okay.
Yeah. I changed. He said today's reminder, but I didn't check the meaning. Okay, then Naveen. In that case, we will wind up.
No, let him come.
Let him come. Let him come. Yeah. Okay. Okay.
Even after this, if they post something,
They will go, they can ask anytime in the Google forum, so
Ah.
that our TA will
that's fine.
replay the.
Yeah.
I'll make an for everyone.